Welcome to another podcast. In this episode, we're going to be taking a look at compound interest accounts. Specifically, we're going to compare how simple interest grows versus compounding annually versus compounding monthly. For this particular exercise, we're going to focus on an initial deposit amount of $12,000 in one of three different accounts. And so let's take these sort of step by step. We'll start with the simple interest account. In the case of simple interest, for the first year, we would be looking at the future value with a $12,000 deposit at a rate of 5% for t equal to 1 year. The future value in that case would be $12,600, so a total of $600 interest was earned. Versus 2 years, the only difference would be changing the t value to being 2 for 2 years, at which point we would have a total of $13,200. And what I want you to see is that the interest was the same. So we started out with $12,000. At the end of 1 year, we'd added $600 in interest. We added the exact same amount for year 2. All right, if I look at compounding annually, this would be where the number of compounding periods is 1 per year. So that's an n value of 1. Maybe we should just remind you of the formulas here. For simple interest, it's P1 plus RT. And for compound interest, it's the principal times 1 plus R over N to the NT. So these are the two formulas that we are using throughout on this video. For compounding annually, we've got 1 plus the rate is 0.05, the n value is 1, 1 times 1. And so what I want you to notice is, because of all the 1's in the formula, this is going to reduce to look exactly the same as the simple interest for year 1. Those two are going to be identical. And in fact, they give the exact same value. So one thing that maybe you should star or just make a remark in your notes is that simple interest is equivalent to annual compounding for the first year only. After that, they're different, because you can see here in year 2, I would have $12,000, and I'm going to apply this rate for 2 years. And so rather than multiply the 0.05 by 2, I'm raising the 1 plus 0.05 to the second. So this turns out to be $13,230. And so what you can see here is I started with $12,000, and in the first year the amount of interest that I gained is identical to the amount of interest I gained with simple interest, because both of them are just let the money sit in the account for a year and at the end of the year add the interest in. However, at the end of year 2, notice that I don't earn the same amount of interest. I actually earn a little bit more. The difference between those two is significantly larger here. It's $630. So I gained in the amount of interest I'm earning. So simple interest, you have a constant growth rate. With compound interest, you have an increasing growth rate. As money increases. Remember, it's proportional to the size of the account. So as the account gets bigger, the amount of interest you earn gets larger. All right, finally compare this with 12 months. And in this case, with 12 months, you would have $12,000 to start with, 1 plus compounding monthly, so the n value is 12, times 1 year. And at the end of 1 year, compounding every month, you would have added in interest 12 times by the end of that year. And at the end of the year, you would have slightly more than what you would have had in either the simple or annual compounding cases. All right, next up is 2 years time. And so over 2 years time, we're going to get even more. So this would be $13,259.30 over 2 years time. So you can see that we ended up with more money. So if you compare the future value here with the future value here, we ended up with more money. And so the idea is compounding more often yields a greater return with diminishing effect. And what I mean by that is, yes, compounding more often will yield you a larger return, but the difference between 1 and 12 is more substantial than the difference between 12 and doing daily, which is 365. The larger your end value is, the less of a return you get, but you do get a positive return. So the more often you compound, the greater the return, but with diminishing effect. Now, one thing that I want to take a look at here is the percent increases involved in each of these problems. So if you look at the simple interest, then the percent increase or the percent change in this problem is, we ended up with an account value after 2 years of $13,200, started with an account value of $12,000, and so the percent change here is going to be equal to 10%. That should make a lot of sense because the simple interest rate here is 5%. And so if it's 5% simple interest, then that comes from 5% in the first year and 5% in the second year. That one's really easy to pick out. That's why it's called simple interest, because the interest is added year in and year out, and it's always calculated on the same value, so it never changes. You can see we've got the constant rate of $600. You're going to gain $600 a year every single year. Compare that with the percent change for the annual case, and the percent change for the annual case would be $13,230 minus $12,000 over 12,000, and that turns out to be a interest rate of 10.25%, or a total return of 10.25%. This is typically called the return. So if I talk about the return on an investment, it's the amount that it yielded percentage-wise. I want to talk about where this 10.25% comes from, because you can't add 5 and 5 and get it. So where are we seeing that? Well, it turns out that it comes from taking 1.05 times 1.05. That's a 5% each year for 2 years. And if you multiply those two numbers together, then the percent there it's the same as this number. And so you can see here that the 10.25% is the growth rate associated with compounding 5% for 2 years. The big difference is each of these represents 5% increase, but I am multiplying them together to get the 10% return rather than adding them together to get the 10% return. So this is what's called compounding. So when we talk about compounding, we are talking about the mathematical process of multiplying the rates. Finally, if I look at the percent change of the bottom one, it's $13,259.30 minus the original $12,000. And you can see that if you calculate that percent change, you can see that the percent change is 10.49%. So there's something interesting going on here where even though I'm telling you it's 5% each year for 2 years, only in the case of simple interest does that equate to 10%. In both of the compounding cases, you actually get a larger return than simply adding the interest for each year would indicate. And that's something to keep in mind, that when you compound interest, the more often you compound, the larger the return, the larger the percentage change. All right, thank you for watching.